So reflection coefficient tells how much the power is reflected from the antenna. As we all know that 100% power cannot be transmitted, and same it will applies to the receiver side as well, that whatever the amount is transmitted by the antenna, suppose 80%, so 80% power cannot be received or detected by the receiver, because eventually there will be losses. So while transmission in the air or through the medium, it will have face some losses, due to which efficiency will decrease. So reflection coefficient will be denoted by tau, which is equal to Zn minus Z naught divided by Zn plus Z naught, where Zn represents the input impedance and Z naught represents the characteristic impedance, which here in case we are having 50 ohm. So Z ohm is globally, wherever the antenna is designing or fabricated or tested, it will have a 50 ohm impedance. At the testing as well, we will have a 50 ohm impedance probe, which will be connected to the connector, which is soldered or connected to the antenna, and hence if the 50 ohm will match, it will have a very good performance and very good results. Also, I will be telling you like reflection coefficient, return loss, and S parameter in case of antenna, what are these, whether it is different or what the formula are. So let's look at the reflected power, how it's calculated with the help of reflection coefficients. So the formula for reflected, transmitted, and return loss are there. Return loss, it is measured in a dB scale, and that's why it's minus 20 log tau. And since whatever we are feeding to the antenna, whatever we are giving the energy is nothing but a voltage source, and that's why again it will be having a minus 20. And in case of current, it will be having a positive 20 log. No, there will not be a minus sign in case of current. And transmitted power is having a formula of 100 multiplied by 1 minus tau square. So hence if both the impedance will be matched equally, so it will have a zero value, tau will have a zero value, and hence reflected power will have a zero, and transmitted power will be 100%. Return loss again, it will be having a minus 20, and which means a very very high good reflection will be there. And if we put reflection coefficient as I have said, so we will get a zero reflected power and 100% transmitted power. So here it is a small animation you can show. You can see here that power is transmitted, and some part is transmitted and some part is reflected, which is a everywhere it will be happen while transmitting, whether in case of message signal or communicative signal. In a satellite communication as well, losses will be there. So let's look at the S parameter. So S parameter tells the relationship between the input and output port of power, basically in an electrical system. If suppose we are having two port system, so we'll be having a four parameters in case of S parameter, which is having S11, S12, S21, and S22 in a form of matrix. And similarly, if we are having three port network, which means three input and three output, I will be assuming that you have studied some basic subjects in your graduation, like network theory or circuit theory, which means in which we have studied some two port network, three port network, and multiple port network as well, which represents in which means two port means two input and two output. Similarly, three port means three input and three output. So here in case, according to that only, S parameter will be formed in a form of matrix. So two port will have a four parameters, three port will have a eight parameters. So let's see what this subscript will means. So in a general purpose, I have mentioned here that if SMMN in subscript, which MN represents the multi-port system, suppose 4 port, 3 port. So if it is written as SMN, which means you can take your own example here. So it will means that power is transferred from port N to M. In this S parameter calculating, people will confuse so easily in order to realize whether the power is transferred from N to M or M to N. Please note that whatever it is written in a subscript, the second digit the power will transferred from the second digit power transfers. So N to M, right to left, the power will transfer. Example I have also mentioned here, S12, which will represents the transfer of power from 2 to 1, and in case of S21, it will represent the transfer of power from port 1 to port 2, and in case of S11 or S22, it will represents the reflection from that port, output power divided the input power, and so on. So it will reflect the reflected power from port 1, and similarly in case of S22 it will be reflected power from port 2. Please note that since antenna is a one port device, that's why when I'll be discussing about the antenna results in a seventh module, that is an implementation module, we will be focusing on S11 only. But in case of MIMO antenna, which is multiple input and multiple output, as the name suggests, it will have different ports. So that why we will be looking on different ports: S11, S12, S13, S14 in case of 4 port MIMO antenna. So other thing is that S11 is the reflection coefficient, as we have studied, and S12 or S21 represents the transmission coefficient basically, because as the definition is transferring of the power and reflecting of the power, that's why it determined as transmission coefficient and reflection coefficient as well. So let's talk about the VSWR, that is voltage standing wave ratio. It is nothing but the ratio of maximum voltage to the minimum voltage, and it is a unitless quantity, and since it's a voltage, that's why we are taking the return loss as minus 20 in scale. The formula of the VSWR is as follows: the 1 plus mod of tau divided by 1 minus mod of tau. Here tau is nothing but the reflection coefficient as well. And if you see that in the last topic, we have covered that tau, if having a zero value means 100% have been transferred, which will give a VSWR of 1, and if the reflection coefficient is 1, the VSWR will be a infinitive value. Other definition, you can also note down that transmitted voltage to the reflected voltage is called a VSWR. VSWR, gain, S11, these are all the important parameters which determines the performance of antenna. So please study more and more about this. So next is bandwidth and axial ratio bandwidth. As you remember, antenna operates at a certain frequency and certain frequency range. So that range of frequency is nothing but the bandwidth, and that range in which the antenna is operating is called a frequency range of operation for the antenna, for that particular antenna. Also, axial ratio is a formula of major axis of polarization to the minor axis of polarization. If both the axes are equal, it will have a one value, which means it is having a circular polarization. And if, as we covered that RSCP and LHCP, please note that this is abbreviated for right hand circular polarization and left hand circular polarization. If the axial ratio value is equal to 1, which means it will have a circular polarization, and within the finite range it is having a value less than greater than 1 and less than to infinity, it will have a elliptical polarization, and if it is equal to infinity, it will have a linear polarization. It is a theoretical concept basically, and also it determines the bandwidth as well. And whenever 3 dB bandwidth is mentioned, it means it is having a axial ratio bandwidth, and bandwidth which is measured less than the 3 dB point. So I will show you some of the graphs that I have that I've made from some of the antennas which I have designed. So the first figure is of nothing but the S11, which is coming around -18 at a 28 gigahertz frequency, which is of 5G, and for the same antenna the VSWR is coming around 1.2. Please note that the acceptable value for the VSWR is between 1 and 2. Since in that frequency range, the transmitted power is acceptable and the reflected power is lower in such that it can be accepted. I will show you more of the graphs and 3D polar plots of gain and directivity as well as side lobe level in the 7th module, so that you can have a better idea over it. So let's talk about link budget and Friis transmission equation.